Hello, we are the Student Safety Sensor team. I am Crisanto Keno Garcia, the project manager. My team members are Antony Matei, Zachary Fung, and Miguel Maulino. So, a little about the conception of this project. We actually came up with the idea because we had personal experiences of near collisions on our doorway coming out of ME106, and we wanted to create a safer way to enter and exit the room. Here is a layout that my chief of electrical engineering, Antony Matei, made. As you can see, there's a servo, a LED light bar, a motion sensor, a light sensor, and LCD screen connected to the Pico. This was the first conception that we created. It was a pretty good layout and it worked really well. This is an illustration we made of how we wanted the Pico and our project to behave. So as you can see, there's motion on the opposite side of the door. Our arm is down and the LED is shining red. Not pictured is the LCD screen, which you will see in action later. And in this illustration, there's no motion on the opposite side of the door. The servo lifts the arm so the user can walk through, all while the LED is shining green now.
So here is the LCD screen we use to let a student know when it is safe for them to pass. As you can see, it says "No Spartan No" on the text display. This shows up immediately after the photo sensor is triggered and indicates that the motion sensor is checking for any moves beyond the doorway. When no movement is detected within several seconds, the LCD screen will change its text to "Go Spartan Go," indicating that the student is allowed to walk through the door. Another indicator that we used for the project was an LED light. By default, it continuously shines yellow and will change to red once the photosensor is triggered. It will turn green once no motion is detected after a good amount of time, thus prompting the gate to lift itself upwards. Speaking of the gate, its mechanical design relies on a very simple pulley-like system that is connected to a servo motor. This motor is glued to a spool carrying a metal cable, which is also attached to a small hook that is secured to the tip of the gate. When it is safe for the student to pass, the servo motor will rotate for approximately 7 seconds, providing enough tension to overcome the weight of the gate. It will then pause momentarily before rotating in the opposite direction until the gate is back to its original position.
For the setup, the bar is in the middle of the doorway to stop the user from passing through. The photo sensor is placed on the wall for easy access. The LED and LCD display is at eye level of the user, so it can be easily viewed. The motor is placed at the top of the door for max tension on the string, and the motion sensor is at the top of the other side of the doorway for max range of detection.
And here is a demo we are doing on the 3rd floor of the engineering building. As you can see, there are actual real students passing by. And when the coast is clear, the arm raises up. And as you can see, there are real-world applications to our project.
Our project turned out to be a success, and it achieved, what we set out to do. It worked as intended, and, it met our objectives that we set in the beginning. The most challenging part of this project was definitely coding. It took majority of the time. It's the majority of our project. Not just writing it, but we had to troubleshoot and testing, and just making sure all the parts connected properly and communicated properly, and just getting it to run smoothly was the bulk of our project. We would definitely upgrade to a stronger motor, giving us, better performance, making it quicker to move the arm up and down, but it would require an external power source. Also, in a permanent setting, we wouldn't use tape. We would definitely fix these to the frames and the walls. And overall, we're definitely proud of how it came together. I think we did great work together, and thank you.
Once again, thank you for watching our presentation on the Student Safety Sensor for ME106 term project. Again, we are Crisanto Keno Garcia, Antony Matei, Zachary Fung, and Miguel Maulino. And thank you and have a great break.